In this video, we're going to discuss resonance. Resonance is one of the most important ideas in all of organic chemistry as it explains stability and reactivity of molecules. When we have resonance, what we are doing is we are moving our electrons around to delocalize a specific charge. If we look at our first example, we have a carbocation and it's allylic because it is one carbon away from a double bond. With our pi electrons, we're able to move them around. They can move from one bond to another as long as they're adjacent to each other. This means that we can have our pi electrons form a bond on the right instead of on the left. After moving these pi electrons, we can rewrite it as this CH2 with now a single bond to the second carbon and a double bond to the third carbon where we originally had the plus charge. With the movement of these electrons, we have moved the plus charge over to the carbon on the right. We can delocalize the electron to two different spots instead of having it all pile up in one location, making it more stable. If we look at the second example, we can also have lone pairs form a pi bond, and then we can reversely have a pi bond go to lone pairs as long as the bonds are adjacent or the atoms are adjacent. If we apply this to the second scenario, we have this negative charge on this oxygen that has three lone pairs, but we can convert one of those lone pairs to a double bond, and what that'll do is it'll repel the electrons from the other double bond and put the lone pairs on the oxygen. And if we draw that out, it would look like the oxygen having three lone pairs now and the negative charge with a single bond to nitrogen, which remains the same. And we now have a double bond on the right to an oxygen with only two lone pairs, which is neutral. Let's look at some more examples. If we look at this compound that's on the left, we can see that we have two double bonds and an overall stable structure. What we can do is move these pi bonds to become a lone pair on the oxygen. Now, if we do that and redraw it, we will have a carbocation where the carbon double bond was, and then on the oxygen, with now this single bond and three lone pairs, we'll have a negative charge. We can form another resonance structure by now moving these two pi electrons one bond over. And by doing this, drawing it right next to it, we'll have the same structure, except we move the double bond. The oxygen still has the negative charge, and we move the carbocation one carbon over. And these are three resonance structures that we can have for this compound. However, if we can get a neutral molecule like the one that we started off with, that'll be the most stable of them all. Lastly, if we look at this compound on the right, we have a carbocation, and it's an ethyl group attached to a benzene. Now, a benzene ring is great for delocalizing charges, and we'll see that in just a second. The way it is drawn, we have a carbocation. We can move this double bond one carbon over to the next bond. That'll give us still this cyclic structure, and our double bonds are in the same spot, except for the one that we moved. And that puts the charge on this carbon here. We can have another resonance structure by now taking this double bond, moving it one bond over. This will give us the same structure with that pi bond moved one over, and our other double bond stays the same. But that means that our positive charge has now moved again. We can repeat this process again by moving this pi bond over one, and that'll give us, once again, the exact same structure with the pi bond moved once, and the charge also moved again. We can have one more resonance structure by taking this pi bond that we moved first and moving it to that adjacent carbon location. By doing this, we get the exact same structure as before, with our pi bond moved one more time and our charge also moved again. With the benzene ring, we can really delocalize our charge, which makes it one of the most stable structures because of how many resonance structures it produces, how much we can actually delocalize a charge that we're given. If you found this video helpful, please consider liking and subscribing as it really helps the channel. And if you want to see more organic chemistry content, the playlist should be on your screen now. Thank you so much for watching.